Hello everyone. Today I'm going to show you how to create a new PipeCash agent. I'm going to explain why you might need to create a PipeCash agent, what a PipeCash agent is, and obviously how to use it. Actually, for how to use it, just see my other tutorials. They're better at that, but I'm just going to go quickly over it. In PipeCash we have scenarios. Scenarios are just some programs. Let's create a random one and enter. So over here, let me just zoom out a bit so that it looks a tiny bit less shit. Okay, so over here we can select agents which are pieces of code which do actions and they connect to each other, and this is well explained in my other tutorials. Now so far so good, but what happens if this list does not contain the task that you need done? For example, it contains some Twitter stuff, but you might want to make a bot that connects to something else. For example, you might want a bot that connects to Telegram chat, and there is no such thing here. It's not present. So what do you do? Well, first you go over here at GitHub PipeCash. PipeCash itself was taken, unfortunately. So at this Git repository, at this Git organization, there are multiple packages. So there is the license for PipeCash, which all these three packages are using. You can read it, by the way. It's pretty interesting license. There is the PipeCash main website, main module, which I don't advise touching for now. It's the central part of PipeCash. What you need are the agents, or the wallets, of course. The tutorial that I'm doing now is pretty much valid for the wallets themselves, because they're designed in a way that is very similar to the agents. So let's open these agents and let's see what we have here. So first, this is a normal Python package, so in order to get to the actual code, we go to the PipeCash agents folder. And in here, we have groups of agents. Each folder is a group of certain type of tasks. I have, for example, a folder for exchanges. However, it's empty. I don't yet have any agents that handle exchanges. But the idea is to be able to automate what happens on your exchange. For example, if you have an account on OKX, you'll be able to, actually I'm not sure if they have an open API, but if they do, you will be able to automate this. You'll be able to create agents that do certain things with your money on the exchange. And this is very useful if you want automatic recharging of funds, for example. Now, right now, we're going to create a certain agent. I have one agent that I really want to create before I go on vacation, and it is going to be, it's the most flexible agent so far. Let me show you. So I have created some issues, and if you want a new agent but you don't want to write it yourself, you can always just create an issue here, and I advise to mark it as enhancement, because that's what requests are, enhancements. And over here you can just write something and give an idea. Now obviously, if your idea is not considered a priority, it will probably wait a long time. I'm doing stuff by the order in which I consider important. If you want something right now, the best way to do it is to submit a pull request. And I'm going to show you how to write the code for that pull request right now. So the agent that we're going to be doing is shell command agent. This is an extremely simple to write agent, but at the same time extremely powerful one. What it does is it simply calls this Python code, os.system execute command. Basically, you give it a command string and it executes it. That's all. This is powerful. This is extremely powerful, and let's actually move into it and see how we can do that. So the first thing we're gonna do is minimize the browser. We're not gonna need the browser, and I have already downloaded the code for this kit. This is the code. You can just clone the repository, and my preferred editor is Visual Studio Code. Let's go in, and inside the PipeCash agent we are going to use the OS folder. Since this is os.system method, it's part of the OS group of agents, so I'm gonna keep it here. I'm gonna create a new file called shell command. And the good thing about os.system is that it is platform independent, as far as I know. It should run fine both on Linux and on Mac and on Windows. Always try to make agents that work on all platforms. And if they don't work on all platforms, always document that in the description. I'll show you how to document it. Okay, so first I'm naming this as a py file, and it's empty. Now look over here. Outside of all these folders, there is one agent called example agent. This one is just a dummy. It's empty. It only contains documentation on what an agent should have. So I'm just going to copy. Actually, let me first show. It has an example minimal agent and an example agent. The example minimal agent shows you what are the minimal requirements for an agent to work. If you don't have these things, your agent is going to fail. So what do you need? You need a start method that accepts a walk, and walk is just a logger from the standard logging package in Python. Then you need empty initializer, empty constructor for your class. It is very important that in PipeCash your agents should be constructible without any requirements, without any parameters. It should be an empty constructor, and that's all. So you need a description always. The description is just a few words about the agent. How does it work? What options are there? What do the options mean? Stuff like that. You need an options object which will accept this option, and a default options object which of course you can leave empty. If you don't have options, you can leave both of these empty, but even if you're leaving them empty, you should include them. So these just specify what should the default options look like if no options are provided. Also, this is what is used in the actual designer. So if I add, for example, this agent, notice that it already has some options. This is taken from the default options object. So if you want this, you should write your default options properly. So we are not going to copy this one, we're going to copy the wrong one, so we can go over everything. So it's copied. I'm just going to rename it to shell agent. The name of the class matters. The name of the class is what appears in the list below, so you have to name it properly. You have to name it in an understandable way. So next, in the start method, we simply accept a walk. So we don't really need to do walk here, other than say self.walk equals walk. And you might want to walk some stuff if it makes sense in your case. You might not want to do that. It depends. So far, most of the agents are not really logging anything because there are no specific edge cases that require this. The standard PipeCash logging is handling most of the situations. but in some cases that might be wise. For example, if you need to advise the user to do something. Next, in the initializer, most of the fields are filled like this, but it's my personal preference to move some of them outside of the initializer. So the options, I like to keep the ones that are not constant inside the initializer and the ones that are constant outside. It's just a quick way to separate between the two. But let's first walk through them. I'm sorry, I started editing too fast. So what are the fields that we can have? Obviously we need a description, options, and default options. I already explained this. We can have a wallet and a user's wallet variable. If you want to use a wallet, this user's wallet needs to be true. If you have that and if it's true, then a wallet will be requested and passed over here. You don't know what wallet will be available. You don't know which object, which implementation of the wallet interface. However, you know that it will have that interface. And I can quickly show you the interface itself. If we go to PipeCash wallets, and then if we go to the examples.py in PipeCash wallet, examples.py will contain again example minimal wallet and example wallet. So what are the things that the wallet provides you? Again, it has some options, some descriptions, and secret variables. I was explaining secret variables, right? These are not the important ones. What is important? It gives you check balance, send, get receive address, and get latest transactions. It follows a certain pattern, it follows a certain template. For example, the latest transactions, this one doesn't give you too much data because some services provide less data than others. And in order to make it compatible with most of them, it simply gives you a list of objects that have amount, total amount moved in the transaction, not necessarily what you consider payment. And if you don't understand what I'm saying right now, then you should learn how UTXOs work. But this is the total amount of money moved in that transaction. This is the time of the transaction, the ID, and how many confirmations have passed since it. Now, if you need to use anything more detailed, you should use the ID to get the transaction from somewhere. It can be any service, depends on your agent. I wish it was a bit more flexible. For example, maybe this one could have included some stuff about uploading files to the MetaNet. But I was designing this before Craig Wright introduced the MetaNet, before he actually made that speech and explained what the MetaNet is. So that's my excuse. Also, in this way, these wallets are actually compatible with BTC as well. And that is important because according to this open blockchain specific license, PipeCash is usable. Let me show you. PipeCash is usable on Bitcoin SV, Bitcoin, which is the BTC right now, but it's just the Bitcoin from block 1 with the most proof of work. That's what I call Bitcoin. It's usable for fiat money, and it's usable for non-monetary practices, for non-monetary purposes. Now you can read that one properly, you can get deep into it and see how it works. This is not the purpose of this video. Let's go back to here. So for the shell agent, we're not going to need a wallet, so I'm going to delete these. We can have an event description, and this one will describe after we run the agent, how will the event look like, what properties, what fields are going to be returned. This is important. So notice that this one was not required in the other area. That is because it is not required to create events. But if you are creating events, it is extremely important to fill out the event description properly. So we are gonna fill that one out. Then we have default schedule. Default schedule is just when will your agent be triggered if it's triggered by a schedule. You can have a default schedule. Right now, this is one of the things I need to improve in the designer. Right now, if you have a default schedule, it will not appear here as a set schedule. This is a problem, and I will work on fixing it after my vacation. It can wait. Anyway, default schedule, we are not gonna need that. We're not gonna need a default schedule. Then uses secret variables. In some case, you want to split some of the options you get provided with between the public options and the secrets. And the whole idea is that if you have some passwords, some private keys for Bitcoin, some very important stuff, you should keep them in a separate area. You should keep them over here. So you should keep them in the secrets. And the way to do that is, for example, if I need 2 keys, I would just write key 1. Actually, the proper pattern is to say with capital letters key 1 and key 2. Obviously, your names need to be marked out. Sorry, my phone is ringing. I'll just leave a message that recording, because I don't want more interruptions. One moment. I'm lazy. I was thinking of cutting this from the video, but I am too lazy to do that. I am recording. Done. So this is how you would specify the keys, and later by PipeCash itself, these keys are gonna get filled with values in this dictionary. You don't need to manage this. You just leave it out to PipeCash. However, we're not gonna use any keys, so I'm deleting this. So of the fields, everything that we are going to use is the description, default options, and the event description. And as I explained, I like to keep the ones that are constant, the ones that are not changing, outside. Basically, like this. Now, I don't need this text, or this helper comments. Next, let's see what we have next. We have validate options. As you understand now, we're going to receive some options over here in this object, and we can validate them to see if they're correct. Now, my advice is to not validate completely. For example, if you're receiving a path to a file, do not validate that this file exists, or do not validate it that it's in the right format. And that is because it can be a pattern. I'll show you in a bit. Actually, let's start step by step. Just go over them quickly and then continue forward. So we have the check dependencies missing. As I explained before, anybody should be able to create a new object of this class, even if the dependencies are missing. In here, you should verify that your dependencies are present, and you should throw an exception if they're not. In our case, we don't really have dependencies that are missing, because we're only using the OS module, which is default for Python. However, if it wasn't, I would write something like this. And this is the simplest way to check dependencies missing, is to just write import OS. And this will fail if OS is not present. Next, as I explained, you want to keep the modules specific to the instance. You want to keep them inside the code, not inside the class, I mean, not outside of it. So one thing I would do here, if this was a module that might be missing, I would just write self.os equals OS. This way, I'm guaranteed that in the check, receive methods and so on, I would still have the exact same object, the exact same module present. However, at the same time, I'm also guaranteed that if this module is not present, somebody would still be able to create this object to get the default options, the description, to completely execute all this code and see if there is a check method, if there is a receive method, because all of this is analyzed by recursion as well. Well, something like recursion. Anyway, then we have actually I'm gonna delete this because, as I said, OS is a standard module, so I'm just gonna import it. When something is a standard module, you don't need to care too much about handling it. However, if it is not, you would need these things. Next is that we have this check and this receive method. Check is for working with the options only. Receive is when your agent knows how to handle arbitrary data, event. And in our case, our agent does not know how to handle arbitrary data. Now the event, I can explain how it works. First, the event is always a dictionary. It is a dictionary, not standard Python dictionary, and it can contain many types of objects inside. It can contain pretty complicated objects or very simple ones. It can be a dictionary with a single field that is just a number, or it can be a dictionary with embedded dictionaries inside with arrays with everything. The whole point is you do not know what it is. It's not in a standard format. The format depends on the agent that is passing this dictionary to this agent. So, in our case, we don't need that. We're not going to handle arbitrary events. We're not going to handle arbitrary data. We're going to handle what is in the options only. So, we're only using the check method then. Actually, let me just go back. Notice that there is the create event object. And now in the description here it's written, you can create events after doing your task. And what's important here is that this create event object will be different every time the check is called. That is important because if you're doing anything that requires multi-threading, you would need to manage which create event object corresponds to which thread. It is important to create your events from the right object, create event object. They are going to be different ones. And the reason it matters if they are different ones or not is because the previous event can be propagated together with the new one. So let's say that, for example, we are pushing this event here. We're creating this event, some key with some value. But at the same time, whatever triggered this agent, triggered it with an event that looks like some key to some value to. Then, at the end, if the propagate origin event option is checked, if it's true, then the end event is going to be a mixture of this and this. And if the key is matching, then the new key will override the previous key. But if it's not, in that case, it will simply merge. Anyway, I'm explaining some fine details. You don't need to care about this if you're not doing multi-threading, or if you are not if you're not doing multi-threading, just create your events normally. You don't need to care about any more details. Now I'm gonna delete these comments as well, and the whole receive method, because we're not gonna need that one, and this comment as well, validate options. I'm leaving the method for validating options because we need to validate our options, but we don't know what options yet. Next, I'm going to make a multi-line string, and let's fill in what our agent will actually do. Execute a command on the shell of the host OS, of the specific OS. Actually, I want to write executes the command, and I would write on Linux it executes in terminal, and Mac, because Mac also uses the terminal, on Windows into cmd command line in the Windows. Now, what options are we going to accept? We are going to accept, so there are multiple ways to do this. The simplest way would be simply command, and it's a single string and they have to fill it in. More complicated way would be to say this is the program name, this is the arguments. The arguments can be a list or can be something else, and we can manage it a bit more for the user. It depends. It honestly depends. Some people prefer to manage it themselves because they're power users and they know how to configure it properly. Others are not so brave because they are not so familiar with the terminal or with the CMD. I don't have an easy solution. For now, I'm going to leave it with simply a command string. Alternatively, and this is also cool, it's possible to have alternative options. It's possible to have command string or program arguments. And if the command string is provided, you simply ignore program arguments. If it's not, then you verify the program and arguments. Okay, let's go with the command string for now. Later, this agent can be extended to include multiple other options, but for now, for the purposes of this tutorial, I'm going to keep it as simple as possible. So I'm just going to say command string. I'm going to say that this is a string. There is no mandatory way to describe this. There is no format required to write this. I have my own style of writing documentation. You can choose to write it in another way. One thing you should know is that this is a valid what is the word? Markdown. This is a valid markdown script. So if you write markdown tags, for example, like the tag for strong text, just a moment, for bold text, then this is bold. This is going to appear as bold text in the designer. So over here, this is the exact work of the documentation, and this is the part that comes from the description. This one is generated separately. You don't need to write everything. But this one comes from the description, and if I had written any valid markdown syntax here, it would have been considered validated and included into the document. So let's go back there. We are not going to use markdown now. I'm just using spacing, and the good news is that the spacing is going to be included in the HTML. So you should consider how you format the looks of your documentation. Okay, next. So command string is just the command to execute. And I'm going to give an example. It's always good to give examples. Example is, let's say, what example should I give? Okay, let's say that we just wanted to create a new file every time. So touch, no, actually that's silly. Unfortunately, right now I'm not gonna write the agent so that it would return the output of the command. I'm gonna do that in a future improvement. For now I'm gonna keep it as simple as possible. So let's make it delete something. Okay, let's make it rm slash. Nah, delete something is also destructive. Something good for an agent would be to copy a file from, I don't know. The problem with this agent is that it is so flexible. It can do so many things that I don't know what exactly I want it to do. But it can trigger any program, and it can. Actually, I'm just gonna write program name. I honestly have no idea how people will use this. It's very flexible. It's very and args. So basically, it can trigger any program with any args. It will not get the output of that program. So if the program you're running with this agent needs to write walk to somewhere, you should specify in the arguments which file to write the walks to. But I'm not going to care for that now. At a later point, I'm going to make it return the output of the program as well. So this is it. This is the whole description. It simply takes a command string format, and this is not an example. It's an example if it's a specific one. This is format. Command string format. I don't want people to get confused that this might be a separate option in the options. I want format to be just okay. So actually, let's use this markdown that I described. This one is going to be bold. Okay, next let's input the default options. Command string, and the default options can include as well some value, and in here we can write a specific command, specific terminal command or cmd command, but this is very generic. This is very powerful, very unspecific, so I don't know what command to write there. Instead, I'm gonna write a pattern, a template. This is a PipeCash template with some value, and this way I'm implying to the users, you should substitute this, or you should connect this from some other agent. It depends on your use case. So in the template, I'm gonna say, for example, this is not valid actually. I'm gonna say like this. I'm gonna say program name plus now I'm going to say program name command, program command plus argument, and then I need to leave space here. What is the argument? Plus name, argument name. So what is happening here? This is a bit strange. Many might not realize what this means, but I'm basically making a template for people when they use the visual designer to fill this in. Usually the idea of the default options is to substitute the options if no options are provided at all. However, with this agent, there is no correct way to fill the default options, simply because it's extremely powerful. There are so many ways to use this agent. So I have no way to know what command the user is going to need. However, they might need this. And one example, here I'll give an example. No, I'm not going to write it in the documentation, but I'm going to give it anyway. So program name, git the command line tools for git. Program command, cloning something from git, space, and argument name is GitHub URL. And if you combine these two, which are just static string, with something that is coming from the event of another agent, then you can have a compose command that ends up being git clone this repository, and it clones the repository that you set to clone to the right folder. This is an example of the usage of the shell agent. And I was supposed to name it not shell agent but shell command. Shell command. Sorry, my mistake. Okay. So event description. How is the event going to look like? Well, we are simply going to return the exit code. Well, think of the event as what you return out of a function. This is a bit more complicated than a function, but to the user it's going to look like a function. So we're going to return exit code, and that's all. And it's usually 0. It doesn't matter what I write here because the event description is simply part of the documentation. It's not anything more complicated. It is simply this part of the documentation. The only reason it is not a string but an object is to ensure that it is valid, that it is parsable as JSON, because while it's part of the documentation now, later it's going to be used for syntax highlighting, for example. It will show, oh, by the way, in this place in the options, for example, in the template here, you wrote exit codes with S at the end, but the name of the option is exit code. Did you make a mistake? Something like that. This is very far in the future. Definitely not a priority right now, but eventually it might get there. So it's important to fill this in correctly. People will use this to connect your agent to other agents. Next, the start method is already implemented. We honestly don't need anything else here. The initializer is already implemented. This one should be kept as wide as possible. You can initialize empty variables here, but you should not do anything complicated. if, for example, your agent needs to get some data from somewhere or to make certain processing before it starts, you should do that in the start method, not in the init. The init is important only so that you ensure that you have some instance objects and to ensure that basically it's possible to create an object. That's all that matters, to make it possible to create an empty object. In some cases you might want to completely not have this one altogether. I'm pretty sure Python creates a default initializer anyway. Next, let's validate the options. So, as I said, we don't want to validate that this is a valid command first, because the user might, even if it is a valid command, the user might not want it executed yet. Validate options happens at the beginning of the agent, and this check method might be called after 12 hours. If you execute the command here, this is bad. This is not by schedule. So in here, you should keep things as simple as possible. What I'm gonna do, and what I usually do for all other agents, is simply assert that command string. Let's see. Yes, I use the highlighting to check if I wrote it properly. In self.options. This is all. We simply assert that the command string is in the options, and then some comment in case it breaks, in case an exception is thrown. The exception message should be that, let's just copy it, command string not in options. And this is all I need for the validation of this agent. In your case, it might be a bit more complicated. You might have alternative option packages. For example, you might have command string or program name arguments. And in this case, you might do some if statements here. You might check, is command string provided? If so, then good. If not, then assert on the other things, are they present? Something like that. There are ways to do it. What matters is to keep the exception messages easy to understand. This is something that the end user might see if they screw up, if they configure their PipeCash scenario wrongly. Okay, next, check. Check can either be scheduled or controlled, and you don't need to care. You should not care if it's coming from a schedule or if it's coming from another event, because you don't get that event anyway. You simply get the options, and the options will be if it's coming from an event, and if this event has templates like this one, then the options will be compiled together to something meaningful. It will be parsed, the template will be parsed and substituted with the actual string or the actual value. In this case, the value is a string because I'm saying this. This is just Python code right here. This marked thing inside the template is just Python code. This Python code and this Python expression will return a string, and this string is going to appear over here. That's everything. It's literally that simple. So we simply know that we're going to receive some options, and these options are going to be hopefully valid. So what do? We already verified that the command string is in the options, so we don't need to redo that verification here. But if you are in a situation where you might get different options depending on, for example, if you have options that are not mandatory. For example, if I have command string, I cannot think of a non-mandatory option. For example, yeah, if I have the non-mandatory option of log the output somewhere, I can simply check is that option set, check what is the location to work the output, and compile together a command that works the output of this command here somewhere in some file. And then I will write some verification code to check if I have these non-mandatory options. But in our case it's very simple, so I'm just gonna write command string equals self.options.command string. Actually it's a dictionary. This is a common mistake. Don't write dot command string. This is not JavaScript. This is not an object. It's a dictionary. So just write it like this. Next, something I like to do just to be safe. I am expecting a string, and the default options are including a string, but there is no way to know if what the user passed is really a string. So I'm just doing this str to be absolutely sure that whatever is arriving here is a string. So next, it's quite simple. I already imported OS, so I'm just saying os.system and then I'm gonna pass the string command string, and it is returning an integer. It executes the command in a subshell. This is good enough for us. I'm just gonna say exit code equals this. That's all. That's everything. Then I'm gonna create an event. And I'm gonna say exit code is the exit code. I'm highlighting again, everything lights up properly. I didn't make typos. What's next? Well, what if, because PipeCash is a multi-threading environment, what happens, and we're not going to change the code. Technically, the agent is done. I'm just going to explain what happens if our command is slow. For example, imagine that this check is called every 5 seconds, and our command here executes for 10 seconds. In that case, before this one is done, a new attempt would be made to call check. Well, good news is PipeCache handles that for you. The new attempt to call check is gonna wait. When check is called, until this function completely finishes, no new calls will be made to it, and this makes programming for agents so much simpler. If you're doing a normal single-threaded command like this one, then you don't need to care about multi-threading. You don't need to handle everything. You just write the command and it works. However, in some cases, for example, this is a proper option here. I can say option background, for example. And if I have an option that is called background, and if it's set to true, over here I can verify, is it set to true? Yes. And if it is set to true, then this and this will go into a separate thread, into a separate execution, into a separate task, so that this method check can end and it can be called again the next time the schedule fits. This can be very useful, but it will make the whole configuration of PipeCache a bit more complicated. If you manage to store which create event object, this function, technically, which create event function corresponds to the specific thread, then you will not have big problems. But nevertheless, I advise you to keep things simple and increment in the future. For now, I'm going to keep it as simple as this. So what comes next is check. Let's check if we wrote it properly. So I'm just going to I'm just going to say I'm gonna write some code here. No, actually, let's write a test. Let's write a proper unit test. Sometimes I'm lazy and I don't write them, but I should, and you should even more, because if you want to convince me that this is working, you should have unit tests. So, first part, let's include this shell command to the actual agents. And the way I'm doing this is, it's not the most beautiful way, but the way I'm doing this so far is to just, actually it's part of the OS, just say, just include everything in the initializing script. So from PipeCash agents .os .shell command import star, and it's going to import all of the classes in that file. Sometimes you need to be specific, but doesn't really matter. It gets connected, that's what matters. Then we go to the tests. First, where are the tests? They are over here in the tests folder. And if you're using Visual Studio Code, I have included the VS Code folder, which will come together with some test configuration. So you'll be able to just use the plugins over here, if you have the right plugins of course, to simply run. If you're using some other code editor, you might need different commands to run your tests. The easiest way is to simply write tox, sudo tox, because I'm on Linux and everything needs a sudo. Sudo tox, my password. Oops, I made type. So my password, and it simply runs. And notice that we already broke the tests. So first, I have a lot of recommendations for better style in Python, which means we have to scroll a lot. We already broke the test. Test all agents. This is a very special test that I have written, which simply checks that all agents we have are connected properly. And what it's saying is that the shell command agent is not listed in expected agents. Okay, let's fix that. This is just a way to verify that everything is connected properly. And in here, this is a bit complicated test. It simply, no, not simply, it uses reflection to verify that all agents are connected properly and pass some very simple verification. It just checks that it's actually possible to put these agents into PipeCash. That's everything. But that's actually plenty. So we'll take the name of our agent, shell command, and we're gonna put it over here. I'm thinking right under the other OS agents. OS as in the OS module. And then if I run this test once again, it should pass. Yes, it passes, meaning we fixed that error. So if you are in a situation where you don't wanna run the tests with unit test, you can run them with tox. Now it's still gonna fail, by the way, but it's gonna fail due to something else, which is unrelated to that new agent. Here, this is something I'll be fixing later. However, I prefer to run the tests from here. So let's refresh and run everything. I have two plugins for tests. It's strange, but in any case, what matters now is that so far everything works, and we need to add our new test. So open new file, and the new file is going to be called test.shellcommand.py underscore dot test underscore shellcommand.py. This is a pattern, and if your file is not following that pattern, it's gonna fail. So in here, I'm simply gonna copy the structure of some other test because I don't want to write it from scratch. So I'm gonna delete the test itself, obviously, and I'm gonna delete this test completely. We only need one test, or maybe multiple, depending on the agent, but in our case I believe one test will be plenty. Once again, sorry, I'll just write that I'm still recording. Okay, so in our case we're using the shell command agent, so I'm gonna copy the shell command name and I'm gonna put it here. Come on. I am also going to keep these. This is the agent wrapper and the wallet wrapper. You actually don't need the wallet wrapper, you only need the agent wrapper. These are part of the PipeCash itself. You don't need to understand everything about how it works. What you need to understand is that if you put an agent inside the agent wrapper, then the right methods are gonna get called. Obviously, you can call your methods yourself if you know the order that you need to call them with, but in our case I prefer to keep it like this. I prefer to use the agent wrapper inside the unit tests. So let's actually copy some more of not here. Okay, let's look at this test, for example, because there is a standard pattern that I usually use for the tests, and for most of these tests it's the same. So what do? I create an events array, and I created a function called createEvent, which simply appends the new event to the events array. This way I can verify what events got created, how many, in what order. Next, I create a new instance of that agent, and I create a configuration. Configuration is not just the options. The options are part of the configuration, but also a name, and sometimes it can include other stuff. It can include, for example, it can include whether or not the previous event should be propagated together with the current one. However, you don't need to test that, because this is test only for the agent. You're not testing PipeCash itself. So let's keep it simple. Okay, next I need to fill this command. After that, I put the agent A into the agent wrapper, and I name the agent wrapper agent. Simple, right? Sorry, I know it's a bit confusing. Honestly, you don't really need to use agent wrappers. You can just call the right methods yourself and verify everything is working. That is enough. I'm just doing it in this way so that I can pass the right configurations through the agent wrapper, which ensures that some procedure is followed. Over here, the final dictionary, this is for the secret variables. You can include secret variables, and these secret variables will be passed as secrets to the agent. Actually, let me show you quickly, very quickly, how does the agent wrapper look like. I'm just going to show you the initialization. It simply creates a walk object in case you need to walk stuff. It actually you do need to, no you don't, the agent wrapper needs to walk stuff later, that's separate. It handles some wallet stuff, it handles origin events, configurations, and then these are the initialization procedures that I was talking about. It initializes everything in the proper order. It initializes options, schedule, secrets, dependencies, everything. This way, you ensure we ensure that in our unit test, what's going to happen is going to look a bit more like what's going to happen in the PipeCash program itself. That's everything I'm doing here, nothing complicated. Now, the run check method is simply gonna run the check method of the agent. It's gonna run this one. That's everything. And the reason I'm calling it with this complicated name is because this is a private method. Python doesn't really have private methods, but it is close to the private method thanks to this double underscore, which is called dunder. Next, we need to write an actual command. What command should we write? Honestly, everything goes. Anything goes. We don't really need to care, but we should write one command that passes successfully and one command that fails. So I'm gonna write command. Let's first rename the test. I just noticed that the test is still named as the other one. So test shell command and test shell command success. So I'm just gonna say ls, which simply lists the files in that folder. I'm gonna keep it as simple as possible, and then I'm gonna run check, and I'm going to assert. I'm using the unit test module asserting functions, which are like so. So I'm gonna assert that two things are equal. I'm gonna assert that the length of the events is 1. Over here the events, basically I'm asserting that this thing got called once. Then I'm gonna assert as well that the first event works, so I need to change the assertion type. Assert ticked equal, so if you're verifying dictionaries you should use that one. And then I'm asserting that the event is going to work like so. And the exit code is 0, because I'm expecting 0 exit code for ls, simply because ls is a simple command. Okay, so far so good. Next, I want to verify that if I repeat this, another event is going to pop up. So I want to verify that the code is not written in a way that will break after the first usage, because agents are stateful, they have state. So in some cases, somebody might change the agent later in a way that breaks it after the first usage. Now obviously it's not guaranteed that this test will catch that break, but it doesn't hurt to have this check. Oh, something I forgot. I need to specify which event. And here it's the first, and here it is the second. It's 0 based index, that's why 0 now. And I'm verifying that there are 2 events now. This is it. This is the whole test for successful shell command. Next I need to regenerate the tests, and it passes here. I can just run everything to show you. Yes, it passes. Now we're gonna create one more, and it's gonna look very much like this one. That's why I'm copying the complete test. It's almost exactly the same test. The only difference is this time we're gonna run it with the wrong command. So I'm gonna write error or no such command. And instead of ls, let's write no such command, something that's obviously wrong, except if there is such a program, in which case it will pass. But these tests are being run in a virtual environment. They're not usually being run locally on your machine, my machine. They're being run on a virtual environment through the TOX framework. So we are guaranteed that this program is not going to be there, even if there is such one. So what I'm expecting is a different exit code. I'm not sure what the exit code is going to be, so let's run it and see. Oops, sorry, it obviously failed, but let's just put a breakpoint and see. So what we have here is exit code, which is this one. Is it guaranteed to be this one? I honestly don't know. I'm not sure how this works. So let's simply paste it there, here and here together, and run the test again. It is successful. Okay, so let's go in Google and verify. Actually, I'm using DuckDuckGo, not Google, but I want to see this exit code. What does it mean? Community. So apparently it's some standard exit code, but I don't know what it means yet. And for some reason this is not loading. Let's try again. Here. Is it? No, it's not gonna work. This is, maybe the website is broken. I'm gonna try again. Exit code to go, and anyway, I cannot find for now what it means. I mean, it's obvious that it means something about subshell and failure, and we obviously expect a failure. But let's see. Actually, let's just read. So apparently it can mean many different things. I'm not gonna go deeper into this. We're expecting it to fail, so of course it's gonna fail. Then what else? We have two unit tests. We have fixed the unit test for all agents, which is this one. We have fixed that one to work. So tests are pretty much done for now. It can be better, obviously. It can always be better, but for the purposes of this video, this is good enough. Next, actually, that's it. What is next is to simply send a pull request with this code and give me a note. Let's actually see the code once again. We included the new agent into the initializer of PipeCash, into the init script. We added the agent itself. We added the unit testing file, and we added the name into the unit testing file of all agents. But this one will detect if names are missing, so don't even think you can cheat on that one. That's it. That's everything. Just send me a code review, send me a pull request, and I'll consider it. I'll probably include it if it's well written, or give you hints if I want something to be better. And that's everything. Thank you for listening. Bye bye.